Okay, so what we're going to look at now is the development of the big five kinematics equations. So these are very important equations to understand and learn. Some of the key things that I want you to note is that these equations are nothing more than just your acceleration equation. And remember, there's vector signs over top of here, but we're just writing them without just to make it faster. So you've got this equation right here, which is your acceleration equation. And then you've got the two for average speed. All you need is, and this really here, these two can be combined into one, really, into one equation, like this. So really, you only need this equation and this equation here to solve any kinematics problem in grade 11 physics. Now, what physicists like to have done is they developed these five key equations from these two equations. So everything we're doing today, you don't have to be able to reproduce. However, you do need to be able to use one of the five equations that we build to solve problems. So the reason we're making them is to make problem solving faster and easier. You could always just use this equation and this equation here to solve these problems, but we're going to find a different way to do it. Now, you all solved the first problems where you found the average speed is v1 plus v2 over 2, and you found for part B where the average speed is delta d over delta t. Well, what this shows you is that really if average speed is v1 plus v2 over 2 and average speed is delta d over delta t, then you could actually rewrite this as v1 plus v2 over 2 is the same thing as delta d over delta t, right? And that's just, I showed you that up above. Since the average speed and average speed are the same, you can just equate the two of them, and that's what you get. And how physicists like to write this is they multiply by delta t, and they get delta d all by itself. And so they write it like this, times time. That is the first kinematics equation right there. Okay, and of course, you can always write down the acceleration equation, right? So this is sort of like number 0. The kinematics equation, that's number 0 kind of thing. But you don't need that. So we're going to see why. So the distance traveled or displacement of an object is v1 plus v2 over 2 times time. Now let's take a look here. Does it make sense? Well, 5 plus 45 over 2 times the time will tell you how far an object traveled. And in this case, well, this isn't actually asking for that, but that's the situation. Okay, next one. This one here, we don't know the distance, delta d. So what do? Well, what you would normally have done when you solved it is you had your acceleration equation, you rearrange for delta t, you rearrange for v2 minus v1 by multiplying by delta t, and then we isolated for v2. And our equation should not have delta d in it, which it does not. And you get 13 meters per second. Now, this is one that we've already rearranged, and we rearranged it from the simple acceleration equation. So our second kinematics equation is this one. Okay, that's our second kinematics equation. Now, that's why I called that other one up there the 0 equation, because this equation that we just wrote down, the second kinematics equation, is just this rearranged. All we did is multiply by t and added the v1. So that is the acceleration equation rearranged. So now we've got 2 equations out of the way. We've got 3 left to go. The next 2 are the same equation more or less with a slight change. So how do you find the distance an object travels if you don't know v2? Well, when you did your question, you went, okay, well, the distance an object travels is average speed times time, but you got stuck and you're like, well, I don't know v2. So you used a different equation, the one from the question 2, and you solve for v2. Then you substituted v2 up here and plugged it in, and you got 14 meters. So now let's work backwards. Let's pretend that we don't know any numbers. So you saw here that what you did is you solved for v2, and you substituted it in there like that. So let's write this out. Delta d is average speed divided by, yeah, that's average speed times time. Okay. And then I said, well, you've got v1 And now it says, what was V2? Well, oh, V2 is this equation. So I'll change the color here just to help out a little bit. Let's go purple. Okay. So what we do is we replace, so there's a plus sign right there. And then we just write, well, V2 is really V1 plus A delta T. And all of this stays over 2. And then there's still the delta T. So notice what we did. All we said was we substituted V2 with V1 plus A delta T. Okay, well, what's V1 plus V1? Well, there's 2 V1s. Over 2. Multiply the delta T into both terms, and you get 2 V1 delta T plus A delta T. Now, delta T times delta T is delta T squared, all over 2. And now the rules of mathematics say that this 2 can divide with this 2, but it can't divide this one out. So if we broke this up, it would be 2v1 delta t over 2 plus a delta t squared over 2. And then those two would divide, and so you're left with v1 delta t plus a delta t squared divided by 2. And that is the third equation. That was a little trickier, but it just used one little clever bit of substitution, and you can see how you get your answer. Okay, you can try it, and if you plug in v1 is 3, if you plug in the time is 2, if you plug in, so like the acceleration is 4, so 4 divided by 2 is 2, the time was 2, so 2 times 2 squared is 8, and 3 times 2 is 6, and 6 plus 8 is 14. So it works out perfectly. So that's the third equation. Now, the next one. Oh, looks identical, except we don't know v1. So to solve for this one, you're going to write out we're looking for the displacement. We know it's just average speed times the time. But here, we don't know v2, or sorry, v1. So we look at our second equation, and we say, well, I need v1. Well, that's just v2 subtract a delta t, and that equals v1. So I just brought the a delta t over, and now I can substitute it up there, and that's all you have to do. So we substitute it in. And we get, if v1 is actually v2 minus a delta t, it's like that. Okay, so now we just gotta do some collecting of like terms, which is simple enough to do. You have a v2 and a v2, so that gives us 2 v2s minus a delta t, bracket, bracket, all over 2 times delta t. Multiply the bracket, the delta t in. All over 2. And then like we did before, the 2's divide here, but they don't divide in that other term. So you get v2 delta t minus a delta t squared divided by 2. Notice how it's almost the same equation as the third equation, except in this case, we have v2 and there's a subtraction. So that's the fourth one. Now we'll take a look at the third one, or the last one, sorry, the fifth one. Okay, so equation number 5. This one people find tricky. In fact, trying to solve for v2 when you don't have the time, but you are given v1 acceleration and distance or displacement, it's tricky because you realize you're like, well, I have this equation, but I only know v1 and acceleration. I don't know v2 and I don't know time. Then here you're like, well, I know displacement, I know v1, but I don't know time or v2, and you're like, what do I do? And so you realize that there's two unknowns. You don't know delta t, and you don't know v2. And the variable that's missing from the whole thing is delta t, but it says it wants us to find v2. So this variable here, delta t, needs to disappear. We need to get rid of it, and then be left with only the terms we know and the one term that we don't know. And so, in this case here, we have two equations, two independent equations, and two unknowns. That is there's a defined solution for these types of problems where you have two equations and two unknowns. And so how do we do it? Well, from grade 10 science, you will have learned this method. Substitution. Really, you're just finding I didn't even write that right. Substitution. What you're doing is you're finding the intersection between two lines, okay? And that we're going to use substitution method. So how do we go about doing this? Well, I'm going to write out the displacement. And I'm just going to write, well, displacement is equal to v1 plus v2 over 2 times the time. Now, look at this other equation over here. I'll do this in a different color. I've got v2 equals v1 plus a delta t. Well, just subtract the v1 from both sides. And then I'm just going to divide by a. Like that. Now I've got delta t and delta t. Well, what do you think you can do? So you've got delta t here and a delta t here. They're the same. So that means I can substitute this little term here in for delta t. So let's do that. So now my delta d is going to look like v1 plus v2 over 2 bracket. And then I just write here v2 minus v1 over a, like that. That's the part I substituted in. This is the same as this and that there. Now, just to make our life easier, we go v1 plus v2, v2 minus v1. On the bottom, you have 2 times a, like that. There we go. Now, because the denominators you just multiply together, and now we know if we multiply the top and the bottom by 2a, or multiply this by 2a, we have to multiply that side by 2a. So we get 2a delta d equals v1 plus v2, v2 minus v1. Now, some of you might at this point, shed a couple tears, but you realize that this is just something important and special, okay? And what you realize is that you need to use the FOIL method or expand the brackets, basically. So you need to multiply v1 into there, and then v1 into there, and v2 into there, and v2 into there. Now, what do we get when we do that? Okay, so let's take a look. We go v1, so it's v1 times v2 minus v1. Now, v1 times v1 is v1 squared. And then here we go v2 times v2. Well, that's just v2 squared. And then v2 minus v1. So it's minus v1, v2. Now, it doesn't matter in this case whether we write v1, v2, v1, or v1, v2, because 2 times 3 or 3 times 2 are both 6 in scalar mathematics in this sense. Even in vector math, it is true for this case. But it gets a little more complicated later about that. But now what you'll see, this term, v1 times v2 minus v1 times v2, this is the same number, right? So they just cancel out because they're the same number. Whether that's 2 times 3 or 3 times 2, doesn't matter. It's the same number subtracted from itself, so it's gone. And you're left with minus v1 squared plus v2 squared, like that. Now it asks us to find v2, so I've got minus v1 squared, so I add it to both sides, like this, and there you go. The final solution for it is v2 squared equals v1 squared 2a delta t. This is one of the most useful equations out of the 5. It gets used all the time. It's so handy. Now, there's some caveats here. Remember, those are warnings that we talked about. When you were trying to find the value for the problem. So let's take a look at the problem that was at hand, actually. Okay. The problem at hand said, what is this v2 if I know that v1 is 3, acceleration is 3, and distance is 4. So we'll solve that here. So v2 squared equals, so v1 was 3 squared plus 2 times the acceleration, which happened to be 3 as well, times the displacement, which is 4. And so v2 squared is, so you go 2 times 3 times 4 is 24, plus 9, because that's 3 squared, is 33. But that's not what v2 is. It's v2 squared that is equal to 33, because the units here are meters squared seconds squared. And so v2, to get the final answer, you take the square root of 33, and it's equal to plus or minus 5.7 meters per second. So it equals plus or minus 5.7 meters per second. Now, depending on the question, you're either going to choose the positive root or the negative root, because remember, it's always good to write this. There's always 2 roots to the solution, almost always 2 roots to the solution, because this is a quadratic formula. So this is quadratic, meaning that there are going to be 2 roots. So whenever you take the square root, there's a plus and a minus. You have to always include that. And whether or not the object is moving forward or backwards or up or down will determine whether you're going to use the plus or minus in your answer. And so that is a big part of this that we need to focus on when we're solving these problems, is when to use the plus and the minus in the solution. So the numerical answer is 5.7, but it's plus or minus. Okay, and then in this case, it's probably just the plus because we didn't pick any other directions to be positive or negative. So we would probably pick the plus in this case. But again, there will be problems where we have to be very careful of that and pick one or the other. All right, those are your 5 equations. We're going to write those on a big sheet.